we will start with the numericals of heat. We will first discuss the type 1. First, I will discuss type 1 with you. And for type 1, we have the following formulae. Q. Now, what is Q? Q is the heat energy which is necessary. Okay. Now, what is heat energy necessary for? It is necessary for two things. Just pay attention. When I convert solid, my solid gets converted to liquid and liquid gets converted to gas, to the gaseous state. Let us take the simple example of ice becoming water and water getting converted to vapor. Now, I have ice. My ice is at 0 degrees Celsius. Now, I need to convert the ice at 0 degrees Celsius. I first need to convert it. Okay, see, please understand this. I need to convert my ice, which is at 0 degrees Celsius. I need to change it to water, and my water is at 0 degrees Celsius. So my temperature is not increasing. So this heat that I supply is used to change the state from ice to water. So when my temperature does not change, I use this formula. The heat energy that is supplied is the mass multiplied by latent heat. What I am doing is I am converting ice into water, right? So this is my latent heat of, I have to call it as latent heat of fusion. So here I require latent heat of fusion. I am writing it with small f, right? Now, after I convert water at 0 degrees Celsius, okay, I need to convert it from water at 0 degrees Celsius to water, but this water has to get converted from 0 to 100 degrees Celsius. So here I am only increasing, I am only changing the state. So my heat energy supplied to change the state is M multiplied by L, that is mass of the substance multiplied by the latent heat of fusion, because I am converting ice to water. Now here when I convert water at 0 degrees to water at 100 degrees, I have to use the formula MC delta T. What is C? C is the specific heat capacity of a substance. When I am talking about water, the specific heat capacity of water is 1 cal per gram degree Celsius or 1 kilocal per kilogram degree Celsius, right? So I am converting it from water at 0 degrees to water at 100 degrees. So I use the formula M, C and delta T. Now after this in my chain, I am going to convert it from water to 100 degrees, at 100 degrees to vapor. Okay. I am going to convert it to vapor at 100 degrees. Now here my temperature is not increasing. So once again here I will use the formula M into L, but this is latent heat of vaporization when I want to convert from liquid to gaseous state. So please understand, when I convert solid to liquid, it has to be solid at 0 degrees Celsius to solid to liquid at 0 degrees Celsius. Then it has to increase, the temperature has to increase from 0 degrees to whatever temperature it melts at, right? No, whatever temperature it vaporizes at, not melts at. Here we are taking, we are allowing it to melt. Here we are allowing it to vaporize. So whenever I increase the temperature, I use the formula QC delta T. When I convert water at 0 degrees to water at 100 degrees, I will use this formula. Whenever I am using latent heat of vaporization, whenever I am changing the state, I will use this formula. Q is equal to ml, right? So this is my first type of sum. Now here I have the first example written for you. The first example written for you. And this example, I'm going to read it out. How much heat energy is necessary to raise the temperature of 5 grams of water from 20 degrees to 100 degrees. Okay. So what is given to me? Can you please tell me what is given? I want to increase the mass of 5 kg of water. So my mass of the water is 5 kg, right? Now we know that the specific heat of water is 1. Because it is kg, I will take it as kilocal per kilogram degree Celsius. Degree Celsius. And I want to increase the temperature. So my initial temperature T1 is 20 degrees Celsius to my T2, which is equal to 100 degree Celsius. Therefore, I can say that my delta T is T2 minus T1, T2 minus T1, which is equal to 80 degree Celsius. My delta T is 80 degree Celsius. Is that clear? Now, how much heat energy is necessary? So I have to find the heat energy required. What is the formula? What is the symbol for heat energy required? It is denoted by Q. It is denoted by Q, right? Now, am I changing the state or am I increasing the temperature? I am increasing the temperature. So I will use the formula Q is equal to M into C into delta T, because I am increasing the temperature. That is why I use delta T. Therefore, Q is equal to mass of the water is 1, C is 1 multiplied by delta T is 80. So, therefore, Q is equal to 400. Okay, it is the energy required. So it is in calorie or kilocalorie. Here it is MKS. So it will be kilocal. Okay. So therefore, answer, heat energy necessary to raise the temperature of water equals to 400 kilocalorie. Unit is extremely important. Is this clear? So this is my first numerical. Okay. Now let us move to the second sum. Let us move to the second question. Correct? Now, question 2. How much energy needs to be supplied to 150 grams of water at 100 degrees to convert it to steam. So now here they have given you latent heat of vaporization, but sometimes they do not give this. You must know latent heat of vaporization of water is 540 and latent heat of fusion is 80 cal per gram or kilogram or kilocal per kilogram, right? So now what is given to me? Correct? It is given to me that the mass of water is 150 gram. I am converting water to steam. I am converting water to steam. So in this case, I am not interested in T1, T2, right? Because I am converting the state. I am making water steam. I am not increasing the temperature. So since I am increasing the state, I require latent heat of vaporization. If it is not given to me, you have to know latent heat of vaporization 540 cal per gram. Cal per gram, right? So what do I have to find out? How much energy has to be supplied? How much energy has to be supplied? So once again, I have to find out Q. Now tell me which formula will I use? I will use the formula Q is equal to M into L. Q is equal to M into L, right? Now, what is M? M is 150. What is L? L is 540. Now, can I multiply 15 by 54? 15 fours are 60. 15 fives are 70. 5 plus 6 is 81. So 810. Okay. And these two zeros. Okay. 0, 0. Okay. Now check the units. The units are generally not a problem here. 81000. What is it? It is cal. Okay, it is cal. So you write your answer. Energy supplied to convert required quantity of water to steam is 81,000 cal. 81,000 cal. This is an important sum. This is example 9A from the textbook. Okay. Now, let's read the sum. Equal heat is given to two objects A and B of mass 1 gram. Okay. Temperature of A increases by 3 degrees Celsius and that of B by 5 degrees Celsius. Which object has more specific heat and by what factor? Now, you know specific heat is C, correct? Right? So, we have to find out which object has more specific heat and by which factor, right? Now, you know that specific heat capacity of water is 1 cal per gram degree Celsius, but it's not always like that, right? Now, for A and for B, for A and for B, right? Let us talk about M, let us talk about C, and let us talk about, they are telling you increases by 3 and 5. So directly they are giving you delta T. So you don't have to write your delta T. Now, what is the mass of A? Now they are saying equal heat is given to two objects of mass 1 gram. So the mass for A is 1 gram and that of B is also 1 gram. Specific heat capacity for A we don't know. So I will say C of A. And for B, I will call it C of B. Now, temperature of A increases by 3 degrees Celsius and that of B increases by 5 degrees Celsius. So I have to find which object has more specific heat, which object has more specific heat, and by what factor, okay. So write that down, which object has more specific heat and by what factor. Now equal heat is given to the two objects, so now I can confidently say that Q of A is equal to Q of B. Actually here I can write this. It is given to me that QA is equal to QB because equal heat I am supplying. QA is equal to QB. I am supplying equal heat, correct? Now what is Q? Q is M, C and delta T. But this is my object A, so I will say CA. And here again M, mass of A. Okay, you want write A here. This is mass of B, CB and delta T. Okay, the increase in temperature for A and B separate. Now this is 1, CA I don't know, and delta T is 3. This is 1, CB I don't know, and delta T is 5. Is that clear? Delta T is 5, right? Now, obviously, this 1 and 1 gets cancelled off on both the sides. We are not worried about this 1 and 1, right? Now, what is the next thing we are going to talk about is, okay, we will say therefore CA upon CB is equal to 5 upon 3. Okay, so who has more specific heat? Tell me who has more specific heat, CA or CB? Obviously, the specific heat of A is greater than the specific heat of B. Okay, so therefore, specific heat capacity of A is greater than the specific heat capacity of B. So, which object has more specific heat capacity? That is very important to write. Okay, so we will write which object has more specific heat capacity. We will say that object A has more specific heat capacity. And by which factor? By how much? So therefore, from this we can say that CA is equal to 5 upon 3 multiplied by CB. So therefore, by the factor of 5 upon 3. A copper sphere of mass 100 grams is heated to raise its temperature to 100 degrees Celsius and is released in water of mass 195 gram and temperature 20 degrees Celsius in a copper calorimeter. If the mass of the calorimeter is 50 grams, what will be the maximum temperature of water? This is my type 2 sum, right? Now here I will use the formula. Okay, the formula I will use out here will be heat lost by object equals to heat gained by calorimeter plus heat gained by the liquid which is there in the calorimeter, the liquid which is there in the calorimeter. Okay, so you can add it to your list of formulas that I gave you first. Now, a copper sphere. So first I am going to write about my copper sphere. Then I am going to write about the calorimeter. We know it's a copper calorimeter. And then about water. Okay, so now we have first the mass, then you have C, then you have T1, you have T2, you have delta T, and in some cases we also require L. What is L? L is the latent heat, either of vaporization or of fusion. Okay, in certain sums we have to use about L, right? So I told you first you require M, the mass, then you require C, that is the specific heat either of the copper sphere or of the calorimeter or of water, T1, T2, delta T and L, delta T and L. Now, a copper sphere of mass 100 grams. So, this is my copper sphere. The mass of the copper sphere is 100 grams. Is heated to raise its temperature to 100 degrees Celsius. So, the initial temperature is 100 degrees Celsius, right? And is released in water of mass 195 gram. The temperature of the water is 20 degrees Celsius. Now, whatever is the temperature of the water, the same will be the temperature of the calorimeter, 20 degrees Celsius, right? Now, what about T2? The temperature attained by the copper sphere, the calorimeter, and the water will be the same. Let us take it as X degrees Celsius. Now, what about specific heat? Tell me, from all these, we know that the specific heat of water is 1 cal per gram degree Celsius. Also, we should know that the copper sphere, most often they'll give it to us, but if they don't, we have to remember that it is 0.1 cal per gram degree Celsius. It is a copper calorimeter. So once again, its specific heat is 0.1 cal per gram degree Celsius. Right? Now, tell me, what is delta T? This is very important. How to find out delta T? Right? Let us see how to find out delta T. Now, this is my copper sphere. It was heated and it was dropped in a calorimeter which had liquid which was at 20 degrees. Okay, so the temperature from 100, it is going to reduce. So here my delta T will be 100 minus X degree Celsius. Is that clear? But in this case, for the calorimeter and water, the temperature is going to increase. So this will be more. So delta T will be X minus 20 degrees Celsius. This 2 will be x minus 20 degrees Celsius. Now in this case, we do not require the latent heat. So we'll put a dash out here. We do not require the latent heat. Okay. So we put a dash out there. Okay. Now let's start with the sum. Okay. This was our table of our given. Now what have we to find? We have to find the temperature of the mixture. So we have to find X basically. Right. Now see here. See how I will start. Now I can say heat lost by the copper sphere. I will call it as Q1, heat lost by the copper sphere. I will call it as Q, not Q1. Let us call it as Q. Now, what is heat lost by an object? The formula we did in the first type of sum, mc delta T. Now, can you tell me what is the mass of the copper sphere? The mass of the copper sphere is 100 multiplied by the specific heat is 0.1 multiplied by delta T. Delta T, I'll just copy. That's why to make this table makes it very convenient. 100 minus X. Now, copper calorimeter, the mass of the copper calorimeter is also given to me as 50 gram. Okay. Now, pay attention. This is 100 multiplied by 0.1. So, I'll write it as 100 into 1 upon 10. Cancel the 0. And this is 100 minus X. So, this becomes 10 into 100 minus X. This becomes 1000 minus 10x. This is my value of Q, heat lost by the copper sphere. Now, after this, I will say heat gained by calorimeter. Heat gained by the calorimeter. This I will call it as Q1. Okay. So, this is equal to m c again delta T. Simple formula. Okay. Now, my mass is calorimeter is 50. Specific heat is 0.1. Delta T is x minus 20. X minus 20. So, just copy it out from there. Now, again 50 multiplied by 1 upon 10. Doesn't it make it easier? X minus 20. So, I'll cancel the 0. So, I will have 5 x minus 20. I can say this is equal to 5x minus 100. 5x minus 100. Now, next one. Heat gained by water in the calorimeter. Again, call this as Q2, which is equal to m into c into delta T. What is the mass of water? Mass of water is 195. Specific heat of water is 1 and my delta T is x minus 20. So, this is equal to 195 into x minus 20. 195 into x minus 20. Now, the last part. This is my formula for heat exchange. So, again I will write heat lost by object equals to heat gained by calorimeter plus heat gained by water. Calorimeter plus heat gained by water or liquid. Okay, this is liquid. Here in this case, the liquid is water. Therefore, my Q is equal to Q1 plus Q2. My Q is equal to Q1 plus Q2. Okay. Now, how much is Q? Okay. So, I will take this on a new page. Okay. How much is my Q? My Q is, see here, what is my Q? So, I'm saying that Q equals to Q1 plus Q2. How much is my Q? My Q is 1000 minus 10x equals to, how much is my Q1? Q1 is 5 into x minus 20 plus my Q2 is 195 into x minus 20. Okay. Now let's solve this. Therefore, 1000 minus 10x equals to 5x minus 100 plus 195x minus 195 into 2 is 390 with a 0, 3900, 190, 3900, correct? Therefore, now this is my minus 10x, I'll keep it as it is, correct? This is plus 95, I get it on this side, so it becomes minus 195x, correct? This is my plus 5x, I can get it on this side, it will become minus 5x is equal to minus 100 minus 3900 is minus 4000 minus 1000. 195 plus 5 is 200 plus 10 is, cancel this negative sign. Now you want to divide 500, let's do it in the rough column. 500 divided by 21. 21 2s are 42, 8 remainder. Bring this 0 down. 21 3s are 63, 170, 8s are. That's enough. So this is equal to 23.8 degree Celsius. Therefore, maximum temperature of water this is my result, this is my answer, whatever you want to call it. A calorimeter has mass 100 grams and specific heat 0.1 kilocal per kilogram degrees Celsius. It contains 250 grams of liquid at 30 degrees Celsius, having specific heat 0.4 kilocal per kilogram degrees Celsius. If we drop a piece of ice, now we are putting ice in a calorimeter, right? This is my copper calorimeter. Which has a liquid in it. Obviously, that liquid is not water because its specific heat is 0.4 kilocal per kilogram degrees Celsius, right? Now, we need to know mass. We need to write C, T1, T2, delta T, and if we require latent heat of fusion. Now let's see what all is given to us. A calorimeter has mass 100 grams. So whatever is given, let's write with red now. 100 gram. Having a and specific heat 0.1. Now they are saying kilocal per kilogram, but it does not matter. We can write cal per gram degrees Celsius. Okay, because it is kilocal and kilogram, it doesn't matter, right? It contains 250 gram of liquid having specific heat 0.4. Again they are saying kilocal, but kilocal and cal per gram degrees Celsius, this does not change, right? Now obviously this is a copper calorimeter. Now ice means we know, water, ice, the specific heat is 1 cal per gram degrees Celsius. Now ice is at 0 degrees Celsius. How many grams of ice? 10 gram. Okay. Temperature of the mixture, that means we don't know T2, so we'll take T2 as x degrees Celsius, which we have to find out, x degrees Celsius, and here also x degrees, because the heat lost by the ice is the heat gained by the calorimeter plus the liquid, right? Now what is the temperature of the liquid? It is 30 degrees Celsius. Here also 30 degrees Celsius, right? Now tell me what will be delta T. Now this is 30, its temperature has reduced, right, because of the ice. So it will become 20, 15, whatever it is, it does not matter. So it will become less. So here we must write, let's write it in blue because we don't know it, 30 minus x degree Celsius. Don't write this here. 30 minus x. This too will be 30 minus x degree Celsius. And this will be x minus, this is 30 minus x, this is x minus 0, but it does not matter. We will write x degrees Celsius. Now what happens is, this is my ice. So my ice is at 0 degrees Celsius. I have to convert ice at 0 degrees Celsius to water at 0 degrees Celsius. Tell me which formula I will use out here. When I want to convert ice to water, the temperature is remaining the same. Only the state is changing. So it is M into L. Very right. Mass into latent heat. So I need to know the latent heat of fusion. Okay. This is 80 cal per gram degree Celsius. Now this water at 0 degrees Celsius has to get converted to water, okay, at whatever temperature. The temperature of the water has obviously increased, right, x degrees Celsius. So this is mc delta T. Therefore, heat lost by ice equals to Q. This is equal to ml plus mc delta T. ml plus mc delta T. Now, how much is the mass of ice? 10. What is the latent heat? 80 plus the mass of ice once again is 10 multiplied by 1 multiplied by this becomes x. So this is 800 plus 10x. 800 plus 10x. You want to write 10x plus 800. It's okay. So I'll write this equal to 10x plus 800. Now, heat gained by the next. Okay. Now, heat gained by calorimeter. Equals to Q1. This is equal to M into C into delta T, because only my temperature is increasing. So what is my mass of the calorimeter? 100. What is C? C is 0.1. delta T is 30 minus x. In the previous sum I showed you. Anyway, I'll do it again. 100 into 1 upon 10. 30 minus x. So this 0 and this 0 cancels. So we get 10 into 30 minus x. Heat gained by calorimeter. 10 into 30 minus x. Right? Now, heat gained by the liquid. Heat gained by the liquid equal to Q2. This is equal to M into C into delta T. What is M? M is 250. C is 0.4. Delta T is 30 minus X. Once again, 250 into 4 upon 10 into 30 minus x. This 0 cancels. So 25 fours are 100 into 30 minus x. Now, please pay attention to this next one. Now, tell me, what is it? Heat lost by ice is equal to heat gained by the calorimeter plus heat gained by the liquid. Okay, isn't that right? So, we will say heat lost by ice, okay, principle of heat exchange, heat lost by ice equal to heat gained by calorimeter plus heat gained by, in this case it is a liquid. Therefore, Q is equal to Q1 plus Q2. Can you tell me what is the value of Q? I got this there, 10x plus 800. How much is Q1? Q1 is 10 into 30 plus x. 10 into 30, 30 minus x. 10 into 30 minus x. Plus what is Q2? 100 into 30 minus x. Let's solve this now. Now there is absolutely no problem. Come on. Let's open the bracket. 10x plus 800 equal to 300 minus 10x plus 3000 minus 100x. Right? So therefore, can I say 800? I'll bring this, yeah. So I will say 800 minus 300, okay, minus 3000 equal to minus 110x minus 10x. You could have brought it this side, right? So this is minus 120x. Now this is 800 minus 300 is 500. 500 minus this is minus 2500. Cancel these negative signs. So therefore, x is equal to 2500 divided by 120. Cancel the two zeros. Now, in your rough work, you divide 250 by 12. 12 twos are 24. 1 remainder. This 10 doesn't go, so you put a 0 on top. 12 eights are 96. Okay, 4 remainder. It does not matter. Therefore, x is equal to 20.8 degrees Celsius. Therefore, temperature of the mixture equal 20.8 degree Celsius. Okay. Lengthy but very interesting